I want to show a feature right now that I use all the time, as recently as just 2 weeks ago when I made this little item in Desmos 3D. The feature I'm talking about works in regular Desmos as well, but this happens to be when I most recently used it. Um, I was teaching my class about quadric surfaces, and so I wanted to show how the quadric surfaces are formed by the conic sections in the cross sections parallel to each axis. So that was the overall goal of the lesson. But the feature I want to talk about is just combining lists so that you can use a family of curves with individual samples of the curve. So let me explain what I mean. Here we have the hyperbolic paraboloid x squared minus y squared equals z. And if I'm interested in the cross sections where, for example, suppose y is a constant. So I set up a list. I set the constant k equal from -5 to -4.5. Those first two elements of the list establish the increment, and then ... 5. This creates a list that goes from -5 to 5 in increments of 0.5. Now I can take each of those constants and use them, for example, to graph the space curve. Well, here it is. These are all of the pathways, the cross sections through the different planes where y equals a constant. So you can see I let x equal t, I let y equal the constant k, and then the z value is t squared minus k squared, because that's what you get when you solve for z here. And it's nice because you can see all those cross sections, all those parabolas that are in that plane. If I orient it so that we're just looking straight on at the zx plane, you can see it as a family of parabolas. But the feature I'm trying to highlight here is, in addition to the family of curves, I like to graph a specific example of the curve. So it looks like I'm just repeating myself. If you look at this first one and then the next one, which I'll turn on now, but now I'm using the A value to just graph a specific member of the family. When I do this in regular Desmos, I typically make the family of the curves, I do them either very skinny, or I maybe even use dashed lines instead of solid lines. But here I just, to make the individual member stand out, I made it thicker than the others. I could have used different colors, but I didn't want to get my diagram too cluttered with colors, because you're going to see there's going to be more in just a moment. And of course, if you have a slider, you might as well animate it. And I will tell you, students are transfixed by this kind of thing. It's very interesting, and it shows the family of parabolas that you get when you let y cycle through various constants. Okay, so that's fun. But of course, you don't only have to do y as a constant. You can say, show me what happens if x is the constant. And now you get the family of parabolas, the downward parabolas that all line up with the xy plane. Excuse me, with the yz plane. And just like before, you can say, now show me an individual member of that family. And again, I made the individual member, I made the line for that individual one thicker. And yes, you can animate and say, look at how we see all the families of downward parabolas that correspond to what happens when you let x equal a constant. Because my goal is, well, in this case, the math goal is that my students see these quadric surfaces as just conic sections being knit together. And as long as we're playing, of course, we should say, well, what if we let z equal the constant? But as it happens, I have to do that in two pieces, although there is another way, but for now I did it this way. And you can see the family of these are hyperbolas that you get. In fact, if you want to see them, look down on this through the, looking straight down the z-axis. There's your family of hyperbolas. And of course, you can see one individual member of the family like that. And then you can animate, oh, I'm sorry, I had to do both branches of it. And you can see the hyperbolas you get when you set z equal to a constant. Now, to me, this offers a level of understanding that you just don't get without something like Desmos. But it's also just captivating to look at. It's beautiful to see. But the number one recommendation I'm making here is that when you make a family of curves using the list feature, that you also then graph individual members of the family and cycle through them so that students can see how the whole family comes together.